Dear students, welcome to third lecture of this course. In this lecture, I am going to discuss concepts and applications of CAD-CAM. So let us start with the terminology that is used for design and CAD. A design is basically an act of working out the form of something by making sketch or an outline or a plan, or it is also called an as the act of converting functional requirements into products. So this is the definition more or less we use in engineering design. And some of the examples of design products are greeting card, web page, highway, gearbox. Okay. On the other hand, CAD can be defined as the use of computer systems that both includes hardware as well as software to assist in the creation, modification, and analysis of design. I would like to mention that here in this course, although design is a bigger domain, the engineering design being the subset of the design. Engineering design here means you are making use of engineering knowledge, whether it is the knowledge about mechanical engineering, manufacturing, civil engineering, electronics, etc., etc., to make something useful for the society or as per the intended functions. But as far as this course is concerned, we will be although discussing the common concepts which are common to all the engineering design domains, whether it is civil engineering or mechanical engineering or electronics engineering. Our focus of this course will be the mechanical engineering design. Now, let us briefly discuss about the computer-aided manufacturing. In computer-aided manufacturing, we basically make use of computer systems to plan, manage, and control manufacturing operations. Uh, the input to the computer-aided design comes from the CAD design results. So basically, this is the basis on which the CAM functions operate. So once the output of the CAD is finalized or your design is finalized, information or the model or the whether it is in the whatever form it is sent to the process planning personnel or the manufacturing personnel, because in industry the persons who may be doing the process planning functions may be from the manufacturing department. The what the process planner does is does the operation selection, operation sequencing, tooling and fixture, and all the other functions related to the process planning, which are essential for producing the part. Um, More often in manufacturing industry, we are making use of ANSI part programming for as far as the use of, because we want to use most of the time the CNC machines or automated systems which are helpful for production. And once the parts are produced or the products are produced, they are sent for quality control, packaging, and shipping. So in all these functions which are within the boundary, gray line boundary, we are making use of computer-aided manufacturing tools. So in this slide, this is a conceptual view to show what is CAD and what is CAM. CAD is basically said to be an intersection of three kinds of technologies. One is the design engineering or the engineering design concepts. For example, mechanics of material, theory of machines, all the fundamental theories, they are part of the computer aided design, because the computer aided design tools, they have all the information in the encoded form, or the information has been programmed, I will say. Then geometric modeling is basically the the CAD model, which has a three-dimensional computer compatible information about the part or the product. And this is being supported by the computer graphics. Computer graphics is how you get the information displayed on the computer screen, for example, or how you take the input to the computer screen for having a useful user interaction. So this is about the three enabling technologies they or concepts which are used in CAD. On the other hand, in CAM, again, it is considered to be an intersection of three domains. One is the knowledge about manufacturing. Other one is the computer-aided design or the geometric model, or all the three basically things which have been discussed in the CAD in for defining CAD or concepts which are being used in the CAD, and networking or network, which is establishing the relationship between the CAD information and the manufacturing knowledge. Maybe it is in the form of the network which is controlling the manufacturing resources, or it is the information flow from computer aided design domain to the manufacturing engineering domain. So all these three concepts are used for having the CAM. Now, um, there are basically very useful things which can be done with the computer aided design. The first thing which can be discussed here is the conceptual design. So with the help of CAD tools, you are able to generate your concept. Reverse engineering is another major application of computer-aided design. Um, you are seeing on the in this slide an engine which has been totally reverse engineered from a 2009 model of a Buell XP12 engine with its all internal components. So what is done in reverse engineering is basically you are converting the physical product to the CAD model. So, suppose you lost, the company stopped producing something because that has become obsolete, but you are somehow in need of manufacturing that thing or creating its CAD model for analysis and many other applications like manufacturing also. For example, an aeroplane, an aircraft, fighter aircraft, which was brought from Russia, say MiG-21. We got an issue with some of its parts. Okay, so those parts are not being supplied by the original manufacturer because they stopped its production. So it is best to reverse engineer that part by scanning the information with the help of a 3D scanner and with the help of the software system to generate its scan model, and that can be followed with its manufacturing and inspection itself. So this is how we can make use of the reverse engineering. Mechanism analysis is another big application where you can make use of the CAD systems to find out or analyze the mechanism or the motion analysis. Okay, I have included a link of the YouTube video which you can refer yourself to see how the mechanism analysis helps in understanding the design of mechanisms. Another major application again is mechanism analysis. So in this example also, you can see that the mechanism analysis helps us to understand the motion of various parts of the disassembly. Another major application is the die design. Suppose you want to manufacture something, some part, and that part is to be made with the help of, for example, injection molding. In that case, you will need two halves of the die, okay, to which is a permanent mold or die, which is to be again manufactured using CNC machine. First thing is its design and then its manufacturing. So both the things can be done with the help of first designing the die by providing all the allowances and all that with the help of a tool which is also called as a die design or mold design. On the left side you can see all the functions which have been used to create this die, and later on these CAD models of this die they can be used for its manufacturing. This is another example of tool design. This is ER32, call it lathe device, which is can be installed on a chuck for fixing the job or the tool. This is another example of application of the CADCAM software. This is showcasing the analysis or mold flow simulation of a plastic injection mold. Okay, so you can see the problem areas where the filling is going to be of low confidence of filling, and the areas where there is high confidence of filling, and you can even simulate the certification process also to identify the problem areas and to make corrections either in the part design or the mold. This is another application of a very important application, I will say, is generation of CNC simulation or manufacturing simulation. So you are seeing this shoe sole model, and with the help of this, the die was designed, and now the two halves of the die are to be machined. So for that, you need to generate the ANSI code, which is a code like this for in this format, which is part of the. We will discuss this in a separate lectures, and you can generate the ANSI code so that the ANSI code can be used on the CNC machine to produce this kind of components or parts of the die. So you can see this manufacturing simulation bending a 3 by 8 inch thick sheet metal using a nonlinear simplification 2D analysis. So this is again simulated in SolidWorks. Okay, so you can see this video in this. This is has been referenced from GrabCAD, and this is the GF that has been prepared to showcase the importance of manufacturing simulation. Uh, Okay, so in this slide, you see another major application of CAD/CAM, that is the inspection planning. So, in what we do in inspection planning, you can do either in CMM, that is the coordinate measuring machine, if you want to automate the process, or you can do with the help of some 3D scanner also. Once the part has been produced, for example, this part has been produced after machining, and you want to inspect its various features, various dimensions. So this can be done on a CMM machine, which is coordinate measuring machine. There is a touch probe available in the CMM machine, which is going to touch the various points on this part. Okay, so this part the wherever it touches the probe touches the part, it will gather the coordinate, that means the x y z coordinate of that point. So similarly, wherever you want this probe to go and find out the coordinates, it can gather that information, and based on that information it can inspect that. Basically, inspection is basically comparison of this produced part with respect to the its CAD model or the design specifications. Okay, so with the help of CMM, and for CMM also you need to program the movement of this probe so that it can go to designated points. Otherwise, it is very difficult to manually take this probe to each and every point. So what do? You make a program. So CNC program or NC code with which it is going to touch the specified points or the pre-designated points to take the readings from there, and then the information is used for further processing like design, inspection, etc. This is another example application of manufacturing planning. You can see this is a structure plus structure analysis, and where you can see how the things are, what is the effect of various kinds of loading on this kind of part. This is a part which is used as a sheet metal component in a computer system. This is again sourced from GrabCAD. Uh, this is an example of a metaphysics, so multiphysics, sorry. So multiphysics is basically when you want to apply more than one kind of analysis. For example, structure analysis along with thermal analysis, which has been done in this case to find out this is a piston, and this geometry is used for both static stress analysis as well as heat transfer analysis. So this is done to uh, estimate or simulate the conditions under which the piston is going to work in an engine. Okay, and this is another example where a full plant can be designed. Like this is an example of a chiller plant design made in Fusion 360. Okay, so this kind of design where multiple components, multiple products, they are interacting with each other can also be designed in CAD-CAM applications. And this is a wonderful example of a digital factory. You can see in this again, you are seeing various components of a factory. Like this is a work cell managed with the help of robot. This is the material vehicle for material handling. Then you have these workstations, different workstations, CNC, and all that, and material storage systems also. And all these things can be simulated with the help of discrete event simulation software, along with the CAD modeling software, where you are basically designing a full factory and virtually simulating the operations. And this has been done in the Dalmian software, which is again a product by Dassault System. Okay, Dassault System is the same which has supplied Mirage as well as Mirage aircraft to the many countries as well as India also, and the same company which is supplying CATIA as well as SolidWorks. Meaning thereby, in with the help of CAD/CAM applications, you can design something, you can analyze, send it for virtual testing, just like we saw some examples. And then after you are satisfied with the design, you can go for tooling design, process evaluation, as well as manufacturing inspection, etc. So a lot of things can be done with the help of computer-aided design and manufacturing tools. This is another example of application of CAD being used for telemanufacturing. So telemanufacturing is basically a concept where a person sitting at home or office can, with the help of internet, can access the repositories of designs, like just like GrabCAD is one repository. You can access the information or models from there, and then you can use those models to adapt those or customize those according to your specifications. And maybe you can send that information to the manufacturing site, so that the same can be supplied to you. And this happens without you having any ownership on the manufacturing resources, which otherwise are very costly. Okay, so this is quite useful. And this is an example of a telemanufacturing models created from South Africa, and they have been supplied to South Africa from USA. So this is all about the various useful concepts and applications of the computer-aided design and manufacturing. So here I would like to highlight a few important benefits of CAD/CAM. With the help of CAD/CAM, the time to market is reduced of any product, And there is, you can remove redundancy of data from conceptualization to manufacturing and so on. And there is a reduced possibility of errors, and costly mistakes can be avoided in both in design as well as manufacturing. Simulation of the design and manufacturing process is one of the important features of CAD/CAM. And because you have reduced time to market, you can reduce the lead time and cost of launching a new product. So typically this is the same as one of the first one. And these are the few examples. Increased number of automobile models being launched these days, new model almost every fortnight. And if you compare with the present time with say 20 years ago, there were very few models which were available in the market. Seldom Maruti Suzuki it could launch a model maybe 3 or 4 years. After 3 or 4 years, or maybe 5 years. Nowadays, each one of the company, one or the other companies, they keep on launching new products, and there are a lot of variants in each product also. A lot of customization kind of a thing, like model variants of the cars and bikes are available. Now, another big example, good example is Boeing 777 time to market was 5.5 years compared to 10 years of the earlier models. So because of all these advantages, often it is said that CAD and CAM combined together is much bigger than CAD and CAM when they are done separately, because of the basically the flow of information. If we have the smooth flow of information from CAD domain to the CAM domain, you can achieve much more advantages rather than using CAD tools separately and CAM tools separately. So thank you.